Hey guys, and welcome back. So I ran 50 frames and I was able to see enough details about the sim, and I stopped at that point because I have few things already that I want to change. And as you can see with this very basic setup, we're getting a lot of details already. If you look here, you see we're getting all these nice separation and all this nice clumping already happening with the default settings. So it's a very good start. Now the main thing that I'm not liking is the speed of the sim. It feels very light, and we're aiming at creating something of a big scale here. About these rocks are about 10 meter, 7 to 10 meter each, and the whole scene here I think is about 40 meters in scale. So we want to convey that, and I want to make it feel a lot slower. So to do that, we're going to first introduce a drag, and then I'm also going to reduce the scale of the source. I think there is too much fluid at this point, and if we're going to use all this stuff in the whitewater emission, it's going to be too much. So we want to have less water, less fluid, but we want to capture all the details and the motion there. So let's start by scaling the source down, and I'm gonna reuse the same scale I had before. I'll just paste it here. So I'm gonna move the source from here to here, and I moved it down as well, so there's a small translate there, but it's 50%, so we're gonna have 50% less points than the previous test. And we want to add some drag. So the easiest way, because we have a particle sim and a smoke sim, we can operate on the particles like as if we're using as if we're doing a pop sim, and we're gonna simply use a drag for this. So I'm gonna add pop drag. I'm gonna set this to 0.01. I'm gonna connect this here, and I'm gonna change few settings in the solver. So something I think I talked about in week 2 briefly, in week 1 briefly, but in DOPS for best performance is actually we have to keep cache simulation on, and we set this to a low number, like 1 or 2 gigabytes. Okay, a lot of things, when a lot of types of sims will not behave correctly if you have cache simulation set to off for some reason. So we tend to set this to 1 or 2 gigabytes 2048 when you submit the sim. Now the trick is, with allow caching, which is under the node here, we turn this off when we submit to do the final sim, and this will reduce the amount of memory it consumes. Now, I'm gonna leave it on for now because I want to get some interactive caching if I can do that. I'm also gonna increase this to 20 gigabytes because I have enough memory and I can use that. If I can cache the sim, I will do that. Okay, so here we set the drag, and then inside the solver, I'm gonna go under particles, reseed. I'm gonna turn this off. We don't want to reseed the particles. We don't want to apply separation. We're gonna turn on vorticity. I'm gonna set this to 0.5, and under droplet we're gonna turn this on. Actually, we'll turn this on later. We'll talk about it when we get there. I'm gonna leave it off for now. And under the velocity smoothing, I'm gonna set this to 0.03. Okay, and we can change this later. We'll do a couple of wedges to see how it looks. And I'm gonna increase this to 0.1. Actually, it's 0.1 now. Let's see how much points we have. Let's run this. If it's not gonna emit too many points, and we can visualize it now, I'll leave the point count as it is. And again, we don't have to have a very high res sim at the main level. We can get by just using 0.1 or 0.075, which is the final setting we used, and we will get plenty of information to work with the whitewater sim. But we're going to show you guys how to mesh this using some advanced technique to get decent mesh out of this. And we're going to do one more trick. Okay, so I'm going to let this run. Now pause the video quickly. So I let it run for 68 frames and it's still caching. I changed the viewport to look straight at the splash, and I'm pretty happy with the result. You can see we're getting really nice motions. Really nice motion here. We're getting a lot of separation. We get some really nice wrapping around the objects as well, and everything is working. Like this part here looks really natural, and the scale feels much better just with that small 0.01 drag. That's all. And I scaled the source just to reduce the amount of fluid. Now you will not be getting these breakups and this variation if we didn't use that sourcing technique, and I should probably have gone into more depth into that, but basically having that randomized breakups where you have gaps and different density in the source helps give you a very broken down source, which helps to create variations later and add more details. Now obviously we had constant velocity to have everything move at the same speed, so and that's what happens, but we can add a little bit more variation if we wanted to the velocity to get more breakups. But again, we're trying to get just a nice motion from the main sim here. The rest of the details are going to come from the whitewater, and so far I'm pretty happy with this. We're going to add one more thing that visually is still missing. If you guys remember from the reference, as the particle separates or as they go up higher, they get dragged and they get more wind resistance. Okay, and these bits are basically the things that are getting isolated. Okay, so if we look here, this guy, all these guys, they are being isolated, and those will they have less density, less neighbors to protect them from the wind, and so they get affected a lot more. And we want to convey that. We want to show that behavior. And one thing I didn't toggle yet in the sim is the droplet. Okay, so let's talk about that. So this is 189 frames, and it took a couple minutes for it to say, we lost the cache because I hit escape. Okay, it's fine. We can take a look here again. So we want to isolate these guys. Okay, we want to find a way when a point or a particle gets separated, we want to be able to flag that. So I'm going to increase this to 0.3 so it's faster to work with. And let's turn on the droplet under the particle motion. I'm going to turn on the droplet. I'm going to increase the range of the min density. I'm going to set this higher, and the max density. So basically what this is saying is if the particle has a density between 1 and 4, we're going to flag that as a droplet. And what that means is when points they are surrounded by this amount of density, so this guy will have 1 point next to it or 4 points, those are the droplets. Okay, that's the droplet range, and that's what the system is going to use. It's going to basically do a point cloud lookup and find the neighbors. If there is not enough neighbors, it's going to start flagging them as droplets. And I'm going to do a test. I will import this, and I want to show you guys how the droplet attribute looks like, and then we're going to do something with that. So it's running now at 0.2. Oh, also, we're going to do a wedge with the smoothing. We set it to 0.03. I know that value is going to work in this example, but we're going to do a wedge to start from 0.1, which is the default, and then go down and see how that affects the look and what that actually does to the sim. Okay, so let's we have these points. Let's go up. Let's create a geo node and call this splash sim import. And I want the path to that, so dop import fields. I want to import the flip fluid, and the path is this guy. And this is the flip object. Cool. And I'm gonna isolate the points, so I'll remove I'll remove them here. So at name equals surface, and at name equal val. Want to delete those guys, and now we have the points. And let's create a point VOP. Or maybe we don't have to use a point VOP. So you can see the droplet value here. We have an attribute called droplet, and if we look through that, it goes between 0 and 1. Let's create a color node. And create a ramp from attribute. We want to use the droplet as the driver. Droplet. Cool. So now you can see the white stuff is what's separating. Everything else that is connected together is black. And so we can say, I'll set this to 0. I'm gonna move this here to 0.7. And I'm gonna blast anything that has a value of at cd.x is higher than 0.5 on delete the points and keep those guys. So this is my droplet information. Okay, and we're going to use this value. We're going to use 0.7 if the droplet value is higher than 0.7. Actually, let's do it here. Let's do at droplet. It's higher than 0.7. We want to isolate the points, and this is everything else. Let's put down a color node. Set these guys to red and these guys to blue, just to show you how it's gonna look like. Okay, so that's our droplet isolation. Now the idea is we want to add a stronger drag to enhance or make these guys drift a lot more, because they are getting separated. We want to have them behave differently. So let's dive inside, copy this guy, and I'm gonna set this to be 2 times stronger. And remember, they're also getting affected by this. So this is global and this is local. I'm gonna call this droplet drag and global drag. And as we did, we're gonna say if the droplet value is higher than 0.7, we want to drag the points using this value. Okay, let's leave that. That's great. And we have verticity, we have droplet. Everything seems to be perfect. I set this to 0.1, and I'm going to actually cache this. So let's create a ROP network. I'm gonna cache 50 frames. Maybe let's cache 100. I'll just have to wait a bit longer. And I'm gonna cache the sim now. So I'm gonna set this to 2000. I'm gonna turn off allow caching in the pop object, in the flip object. And let's change this to NAS sim water effects. And let's call this splash flip. Geo.sc, and let's make sure we use a fluid compress node and link the particle separation. So let's go up and copy this, right click, particle separation, copied, and yeah, let's leave it at 100 and try to think what else. That's it. I'm gonna hit render and we'll wait for the cache and continue next video.